Hello everyone, this is Varsha. I'm currently pursuing my BE in 6th Sem CSE AI department in Sri Venkateshwara College of Engineering. In this session, we will discuss about OTEC power stations in the world. Firstly, our agenda in this session is Introduction to OTEC power stations, advantages of OTEC power generation, current OTEC projects in the world, OTEC potential in tropical regions, challenges, environmental impact, and technological advancement. Introduction to OTEC power stations. What is OTEC? OTEC means Ocean Thermal Energy Conversion. It is a renewable energy technology that harnesses the temperature difference between the the warm surface waters of the ocean and the colder deep waters to generate electricity. OTEC power stations operate based on the principle of exploiting the natural thermal gradient present in the ocean. These OTEC systems utilize the temperature difference between the warm water, typically around 25 degrees Celsius to 30 degrees Celsius in tropical regions, and cold deep water, that is around 5 degrees Celsius to 10 degrees Celsius, found at depths of about 1000 meters or more. This temperature gradient can be substantial and is a constant feature of ocean environment. There are mainly two types of OTEC systems. One is closed cycle and other one is open cycle. In closed cycle systems, a working fluid with a low boiling point, such as ammonia, is vaporized by the warm surface water to drive a turbine, and it's condensed by the cool deep water to complete the cycle. In open cycle systems, warm surface water is directly working fluid to vaporize a secondary fluid such as ammonia and drive the vaporized working fluid in closed cycle systems or the steam generated from the warm surface water, that is in open cycle systems, drives a turbine connected to a generator. It produces electricity. This electricity can be used to power various applications, including desalination plants, onshore facilities, or sent to the grid. OTC technology has the potential to provide baseload power, meaning it can generate electricity continuously, unlike some other renewable energy sources like solar, wind, which are intermittent. OTC can also be integrated with other systems such as seawater desalination plants to provide fresh water in addition to electricity. OTC systems have the potential to produce clean, renewable energy without emitting greenhouse gases or other pollutants during operation. This is one of the most advantages in the OTEC system. However, the construction and operation of OTEC facilities may have environmental impacts such as altering marine ecosystems or affecting ocean currents. Let us see the advantages of the OTEC power stations. The first advantage is it is renewable and continuous. OTEC harness the temperature difference between warm surface waters and cool deep waters, which is a constant and renewable resource. Unlike solar or wind energy, this can produce continuous baseload power, making it a reliable source of electricity. The next advantage is low greenhouse gas emission. OTC power generation produces minimum greenhouse gas emissions during operation. It does not rely on the combustion of fossil fuels, so it contributes little to air pollution and global warming compared to conventional power plants. Next one, abundant resource. The ocean covers more than 70% of Earth's surface, and it contains a vast amount of thermal energy that can be harnessed through OTEC. This resource is particularly abundant in tropical regions where the temperature difference between the surface and deep waters is significant. Next one is versatility. OTC technology can be used for various applications beyond electricity generation. Now, let us see various OTEC power stations in the world. The first one is Hawaii OTEC. The Natural Energy Laboratory of Hawaii Authority operates an OTEC research facility in Hawaii. It is one of the most well-known OTEC projects, although it's primarily a research facility rather than a commercial power station. Next one is Japan OTEC. Japan has been actively pursuing OTEC technology due to its geographic location and interest in renewable energy. The Okinawa prefecture in particular has shown interest in developing OTEC projects. Next is India OTEC. India has also expressed interest in OTEC technology. The Indian government has collaborated with organizations like National Institute of Ocean Technology, that is NIOT, to explore the feasibility of OTEC projects. Next one is Reunion Island. It is located in the Indian Ocean. Reunion Island has an OTEC plant operated by DCNC, a French naval defense contractor. It's a significant project in terms of demonstrating OTEC technology and real world conditions. Next one is Guam. Next one is US Virgin Islands. The US Virgin Islands have explored the potential for OTEC as part of their efforts to increase the energy security and sustainability. Next, let us go with the OTEC potential in tropical regions. Tropical regions near the equator have immense potential for OTEC power generation. The consistent warm surface waters and cool deep ocean temperatures in this area provide the ideal conditions for OTEC plants to thrive. Countries located in the tropics, such as small islands, nations in Caribbean, Pacific, and Indian Oceans, are particularly well suited for OTEC deployment. These regions have high electricity cost and heavy reliance on imported fossil fuels, making OTEC a promising renewable energy solution. Next, the challenges in OTEC deployment are high capital costs, technological complexity, location dependency, environmental impact. Next, let us go with the environmental impact of OTEC systems. Ocean intake and discharge. OTEC plants require large volumes of seawater, which can potentially disrupt local marine ecosystems through intake and discharge of large quantities of warm and cold water. Next, OTEC plants require large volumes of seawater, which can potentially disrupt local marine ecosystems. OTEC plants constructed near tropical coastlines may alter local currents, wave patterns, and sediments. Next, technological advancements in OTEC, that is innovative designs, renewable energy focus, and thermal efficiency. Thank you.